Now we're going to work on sublevel 2 of Newton's Laws modules. And you can see that the objectives of this one is that the student should be able to relate the presence of balanced and unbalanced forces to the state of motion of an object. And that students should be able to relate force diagrams and force information to information describing the motion of an object. So once again, we have our Minds on Physics note sheets that have all the questions so that we can quickly find the answers to this. And the first one here, it says a ball is thrown vertically upwards. After the ball is released and is moving upwards towards its peak, it slows down. During this, when we throw a ball up, it acts only, it's only gravity that acts on it if we neglect air resistance. All right, so when we throw a ball up, only gravity pulls it down. And that's an unbalanced force because there's only one force acting on it in the downward direction. So we need to know that to answer that question. When all individual forces acting upon an object are balanced, it is a natural tendency of an object to maintain its state of motion, whether it's at rest, like the normal force and the gravitational force are at balance on this, or whether it's moving in different directions, but it's moving at a constant rate because all the forces are balanced. Right? When forces are unbalanced, things accelerate or change velocity. All right? So now we have a question where Mr. Smith guides a golf ball around the outside rim of a green at the hole-in-one putt-putt golf course. When the ball leaves the rim, we did our sample with the hoop and the ball bearing. That when I raise the hoop, Brandon, what happens to the ball bearing? It goes in what type of motion? Straight line, constant velocity, constant motion, straight line. Right? So that's because when it leaves the hoop, the only forces acting on it are gravity downward and the surface normal force upward, and they're balanced. So it maintains a straight line, a straight velocity, a straight speed, constant. No acceleration takes place. All right, so the forces acting upon object are balanced. Therefore, we can be absolutely certain that the object is not accelerating. Okay, it is not changing its motion. It's not changing its velocity. When forces are balanced, it does not change its velocity. It maintains either being at rest or it maintains being in motion. But we don't know if it's in motion or at rest. We just know that it's maintaining its state of motion. Forces that are not balanced accelerate. So they either go faster or slower or change direction. Forces that are not balanced change velocity. They change its state of motion. And we know that for a fact. If you were in a spaceship and fired a cannonball into frictionless space, the amount of force needed to keep this cannonball in motion would be what? 0. Very good. All right, so once this cannonball is pushed in outer space, it continues forever. Just like when I kick a bowling ball across the floor, how much force is necessary to maintain it rolling across the floor?
None.
None, because once it's in its state of motion of moving, it wants its inertia, its heavy mass inertia wants to maintain that state of motion. Or an object moving at a constant velocity must have balanced forces acting upon it. It's not changing velocity. It's not changing direction. Okay, so an object moving at a constant velocity is experiencing balanced forces. It's not changing direction. It may be at rest, it may be in motion, but it has to maintain its state of motion. All right, now we have the diagrams below depict individual forces acted upon by an object. Each arrow represents a force, and the length of the arrow represents the size of the force. Based on this information, which object could be moving rightward? All right, so we can go to a website. We can go to sciencewithmrnewton.com. All right, we can open a second window there, and we could look at two interactive simulations from the University of Colorado physics department. One of them shows a box with its vectors being pushed back and forth, and the other one is our lunar lander game, which a lot of people have seen. And when you do this, you'll notice that when you show your vectors, right, you'll notice that even though we have forces acting up and down, that doesn't necessarily mean it moves in the direction the arrows are pointing in, okay? Because if it's already moving in one direction, all right, if it's already moving in one direction, it has to decelerate from that force to the other direction first. So it has to decelerate to 0, and then it can accelerate in the other direction when that force is applied to it. So any one of these force diagrams, which are all instances of time, any one of them could be moving to the right. We don't know enough about what its previous motion was to answer this question as to exactly what direction any of these boxes are moving in. They could be moving in any direction, and this instant of time doesn't tell us enough information. So all the answers are correct. Any one of them could be moving to the right. So close that one up. All right, so now we have...
it says at a constant speed, though.
So here we have the next one talks about at a constant speed. All right, so this one says moving rightward. Some of them, like we said, could be moving rightward at a constant speed. That's over here on the next one over here. So we're not on that one yet. This one here says the oil drop diagram depicts motion of a rightward moving. And this oil dot diagram does depict it at a constant speed. If it's at a constant speed, Brandon, then what does that mean that we learned?
It has to be balanced.
They have to be balanced. So we look at these diagrams, and this one's not balanced, and this one's not balanced. This one is balanced, and this one is balanced. So only the ones that are balanced, only the ones where the forces are balanced can show a constant speed. All right? So ones that have unbalanced forces on it will be accelerating in some direction, and ones that have constant speeds have all their forces balanced, whether they're in motion or at rest. Okay, and now that you know that, you can complete all these questions successfully for sublevel 2 of Newton's laws, Minds on Physics modules.